Let us understand these concepts by considering some situations. Here is a bag in which there are 3 red balls. If we take out one ball without seeing in it, will it be a red ball? Think. Absolutely right. Here, without seeing these 3 red balls, getting one red ball is certain. Is it also certain that if we draw out one ball from 3 red balls without seeing in it, then it can be a green ball? Think. Definitely, your answer will be no, because taking a ball without seeing 3 red balls and getting a green ball is impossible. Now, look here. Here is one coin. Can you tell whether we will get a head or a tail in the experiment of tossing the coin? Think. Here, we certainly cannot predict whether we will get a head or a tail. In such a situation, getting one from either of these two is a possibility or a chance. Because these both are possible outcomes. But in this situation, the possibility of getting a head and the possibility of getting a tail are equal. In such a situation, we say that the outcomes are equally likely. Here, both head and tail are equally likely outcomes. Here we have done an experiment of tossing the coin, the outcome of which can be head or tail. Each outcome of an experiment or a collection of outcomes forms an event. Like here, getting head is one event, and similarly, getting tail is also one event. When a coin is tossed, then the outcome can be either a head or a tail. We will represent head with H and tail with T. In this way, we can say that all the outcomes of the experiment of tossing the coin are HT. The possibility of getting of each from these is 1 out of 2, that is 1 by 2. We say that probability of getting head is 1 by 2 and the probability of getting a tail is 1 by 2. In this way, probability tells us that what is the possibility of happening of any event. In this way, probability helps in measuring the possibility. In standard form, probability of an event is equal to number of favorable outcomes of event divided by number of possible outcomes of an experiment. For example, the number of all possible outcomes when a coin is tossed is 2 and number of outcomes favorable to the event of getting the head is 1. So, the probability of getting head is 1 by 2. Now look at this spinner. It has yellow, red, green, pink and blue colors with equal areas of paths. Can you tell what would be the possibility of stopping the spinner at pink color when it is spinned? Think. Let us tell you. Here the area of all colors is equal. That's why the possibility of results will be equal, that is, outcomes are equally likely. In this experiment, there are total 5 possible outcomes. But out of these 5, favorable outcomes is only one, pink color. In this way, on spinning the spinner, the possibility of stopping at pink color is 1 out of 5. We say that on spinning the spinner, the probability of stopping at pink color is 1 by 5. If the outcome of event is certain, the probability of that event is 1. And if the event is impossible, its probability is 0. Like in a bag containing all the red balls, if a ball is taken out, then it will be a red ball. So, the probability of getting a red ball is 1. But it is absolutely unlikely to be a green ball. So, the probability of getting a green ball is 0. But when the event is likely to occur, then the probability is greater than 0 and less than 1. Now you must have understood probability. So, today we have learned about chance and probability. In the next video, we will see some interesting examples related to chance and probability. Probability. Read the following situations to find out whether they are certain, impossible, or can happen by chance. If the price of one chocolate is ₹5, then price of 10 chocolates will be 50. If we know the price of one item, then we can find the price of any number of items. Here, considering the price of one chocolate, it can be said certainly that the price of 10 chocolates will be 10 multiplied by 5 rupees is equal to 50 rupees. Therefore, the outcome of this event is certain. On throwing the dice, 8 will be obtained. On dice, only number 1, 2, 3, 4, 5 and 6 are marked. Therefore, it is impossible to get 8 when the dice is thrown. On randomly choosing a student from a class of 12 boys and 8 girls, it will be a boy. Here definitely, number of boys is more, but this does not mean that if a student is selected randomly, it will be a boy. It can also be a girl. That is, if a student is selected randomly, it will be a boy by chance, means possibility. Next example. On throwing the dice, find the probability of getting the odd number. All possible outcomes of experiment of throwing the dice are 1, 2, 3, 4, 5, 6. Therefore, all possible outcomes of the experiment are 6. Here, we have to find out the probability of getting the odd number. Favorable outcomes for obtaining the odd number is 1, 3, 5. In this way, for getting the odd number, the number of favorable outcomes is 3. Probability of any event is equal to number of outcomes for that event divided by number of all possible outcomes of the experiment. Hence, the probability of getting the odd number is number of outcomes for obtaining odd number divided by number of all possible outcomes of the experiment. In this way, the probability of getting the odd number is 1 by 2. Similarly, can you now find out the probability of getting an even number on throwing the dice? Try yourself. Next example. On some chits, each letter of the word intelligent is written and placed in a jar. If a chit is drawn from the jar without looking into it, what is the probability that N is written on it? Intelligent, this word has total 11 letters, that is, the number of chits will be 11. Therefore, total number of outcomes will be 11. This word has 2N. So, there will be 2 chits on which N will be written. The chit drawn in this way, there are 2 favorable outcomes for N. Hence, the probability of having N on the drawn chit is the number of favorable outcomes of the event divided by number of all possible outcomes, which is equal to 2 by 11. Now, you can find out by your own that what is the probability that a vowel is written on the chit. So today we have learned some examples related to chance and probability. In the next video, we will see some misconceptions related to probability. Misconception 1. On tossing a coin 15 times, following outcomes are obtained. Find out what will be the result if the coin is tossed next time. Some children see the pattern and think that on tossing a coin, next time outcome T will be obtained. So, they give option 1 as an answer, which is the wrong answer. In such an experiment, it is wrong to predict the outcome based on observations. Keep in mind that after tossing a coin, it cannot be said certainly that we will get a head or tail. The outcome will neither depend on any pattern nor on earlier observations. The coin is tossed any number of times, but in every case, there is equal possibility of getting head or tail. That's why we say that the probability of getting each outcome, head or tail, is 1 by 2. So here the correct answer is option 2. Misconception 2. In the shown spinners, there are 2 colors. According to Ramesh, the probability of stopping on blue color of all 3 spinners is 1 by 2. But according to Manish, in the first spinner, the probability of stopping at blue color is 1 by 2, 1 by 4 in second and 3 by 4 in third. Find out whose understanding is correct. Like Ramesh, some children think that each spinner has 2 paths, one blue and one green. So the spinner will stop on one of these 2 paths. That is, the probability of stopping on the blue part of spinner in all 3 spinners is 1 by 2. But this is a wrong understanding. That is, option 1 is wrong answer. Here the first spinner has 2 equal paths, so all possible outcomes will be blue and green. That is, the number of all possible outcomes is 2. But condition of getting blue color is only 1. So, the number of favorable outcomes is 1. In this way, the probability of getting favorable outcome, blue color, is equal to number of favorable outcomes divided by number of all possible outcomes of an experiment, which is 1 by 2. On doing 4 equal parts of second spinner, there are 3 green parts and 1 blue part. That is, the number of possible outcomes of the experiment are 4. From these, the condition of getting blue color is only 1. Therefore, the number of favorable outcomes of experiment are 1. We can say that the probability of getting blue color is equal to 1 by 4. On doing 4 equal parts of the third spinner, there are 1 green part and 3 blue parts. That is, the number of possible outcomes of the experiment are 4. From these, the condition of getting blue color is 3. Therefore, the number of favorable outcomes of experiment are 3. We can say that the probability of getting blue color is 3 by 4. In this way, the probability of getting blue color in first spinner is 1 by 2, in second spinner is 1 by 4, and in third spinner is 3 by 4. That is, option 2 is correct answer. Keep in mind that in such situations, that probability does not depend on the number of colors, but on the number of equal parts. So today we have learned some misconceptions related to chance and probability.